This video is for section 2-6, Statements and Converses. Here are two statements. If x equals 11, then 3x plus 5 equals 38. Now look at this statement. If 3x plus 5 equals 38, then x equals 11. Do you see the relationship between these two sentences? Statements like this, where the hypothesis of one statement is the conclusion of the other, are called converses. You can combine a sentence and its converse like this. 3x plus 5 equals 38 if and only if x equals 11. The reason for mentioning this is that many algebra theorems use the phrase if and only if in the middle of the sentence. So it's important to understand why that's there. Here's an example of a theorem that does that. Let a and b be real numbers. A times b equals 0 if and only if a equals 0 or b equals 0. Because of that phrase, if and only if in the middle of the sentence, this theorem is true in both directions. What I mean by that is, if we have a situation where we have two numbers multiplied together and we know the answer is 0, we can conclude that the first number is 0 or the second number of 0. But the theorem works in reverse. If we have the situation where we have two numbers and we know that one of them is 0, then we can conclude that if you multiply them together, the answer is 0. So by using that phrase, if and only if, in the center of the theorem, we expand the meaning of the sentence. The theorem is true in both directions. Let's use the theorem to solve an example problem. X plus 3 times x minus 1 equals 0. We have two numbers multiplied together to equal 0. Therefore, the first number equals 0, or the second number equals 0. I'm applying the theorem that we just discussed. Now we can solve both of these. Subtract 3, and on this one over here, add 1. So there are two possible answers for x. It can be -3 or +1. Substituting either number into the original problem will create the answer 0. Let's try another example. Solve t times t minus 1 times 2t plus 3 equals 0. We have numbers multiplied together and the answer is 0. Therefore, one of those numbers must be 0. T equals 0, or the second number equals 0, or the third number is equal to 0. Now let's solve these. The first one is already solved for t. This can be solved by adding 1 over there. This one can be solved by first subtracting 3 and then dividing by 2. So there are three possible answers for t: 0, or 1, or -3/2. Let's summarize the lesson. We discussed theorems that contain the phrase if and only if. In this case, either part of the theorem can be considered the hypothesis, while the other part is the conclusion. We looked at a specific theorem involved multiplying two numbers together where the answer is 0. And concluded that one of those numbers must be 0. And we did some example problems with the theorem.